Okay, for today, we are learning a new thing about how to multiply these complex numbers and add them and subtract them and doing all of this in cis form. So cis form is like really a big deal. Which one of these is cis form? Complex rectangular or complex polar? Polar. Now, they don't call it cis form anywhere in the directions. I do because it's a really easy way to say it. You know this, I think, that it'll have a number and then cis, an angle. And the CIS stands for again, do you remember? Cosine, I, sine. Okay. And if I knew the R, I could put it right there. And that's pretty easy if you knew this. And at that side is a 2. And therefore, this is the 1, 2 square root of 3 triangle. And I'm a 30 up there and a 60 down here. So I think it's 2 cis 60, and your math teacher would laugh at you and mark it wrong. Why? Because you have to have it in radians, so pi over 3. And how about the rectangular form? There was a gentleman in the back that was working on that one for me. What do you think the rectangular form is? 1 plus root 3i. You are correct. Okay, so if they ask you for complex rectangular, you do the top one. If they ask you for cis form, they're not going to say cis form. What are they going to say? Complex polar. All right. So, or polar complex. I've seen it written that way more than the other way. So it doesn't matter as long as you have both words. You've got to connect the two. All right. So what if I had something like 2 cis pi over 3, this dot right here, and I wanted to multiply it times another 3 cis pi over 6 or something like that? Well, what do? You multiply everything? No, it's not quite that simple. Take a guess what you do. This is kind of intuitive, and I think somebody's going to pull it off without any special prompting. And by the way, picture-wise, I get that a lot of people aren't going to like see the answer as making any sense. Like the dot for 3 cis pi over 6 would be like here. And the other dot was back here. And if I multiply these two dots together, I get a third dot, which is like completely different. And they don't necessarily totally make sense. So you can't just look at the pictures and go, oh, I see. You have to have a system. 2 cis pi over 3. 3 cis pi over 6. Come on, somebody take a shot at it. It's not that complicated. 6, very good. 6, because you multiply the numbers. Cis what? Take a guess on this part now. What do you think we should do with pi over 3 and pi over 6? No, you don't multiply them. It would make a really small, weird number that you would never be able to use logically. Add them. Very good. Multiply and add do kind of go together. Pi over 3 plus pi over 6. I'm going to write it here just so you see what I'm doing. And then I need to put that into a common denominator. Would you agree that pi over 3, if I multiply by 2 on the top and the bottom, becomes 2 pi over 6 plus 1 pi over 6, which makes a total of 3 pi over 6. So 6 cis 3 pi over 6. This dot times this dot equaled a dot that's way up here. If I could move this whole thing down a little bit, I could do this. Second. And its final answer is a dot that's like way up here at pi over 2. So that times that makes that. Do you see how picture-wise this doesn't make much sense? Okay, but we don't have to do it picture-wise. This way it makes a lot of sense. 2 times 3 makes 6. Pi over 3 plus pi over 6 makes, when you get the common denominators right, 3 pi over 6. And then I simplified that to 6 cis pi over 2. That's why pi over 2, the angle is straight up, that angle. It was up 6, and then the angle was pi over 2, because that's like a 90-degree angle, like right there. Okay, so let's see if you really understood that. 2 cis pi times 4 cis pi over 2. Try to figure out what that would equal. I'm going to warn you. Instead of just like saying, ha, you're all wrong. There's a trick to this one when it comes to the angle. Be careful. Pause for a second while you give this a try. Okay. You should have done 2 times 4 is 8. Cis pi over 1. I'm doing that weirdly to show you how to add it to pi over 2. And then this is times 2 is 8 cis 3 pi over 2. But I warned you that wouldn't be that simple. So if you got that far, that's a good start. Yes. Oh, yes. Negative pi over 2. Why? Because if you look at it, here's where it is. It's down here. What's so wrong with saying 3 pi over 2? Can't go past pi. So then you got to go the other way and say negative pi over 2. Very good. Okay. So that's multiplying 2 things in cis form. Just take a wild guess if I had changed this whole problem to dividing by. It wouldn't be that hard. What do you think the first number would be? 4? 2? How about 2 divided by 4, which is 1 over 2? Very good. Do you get what I just did there? I just divided the 2 front numbers instead of just multiplying the 2 front numbers. And then how about this part? Pi and pi over 2, do you think I should add them? Well, subtract them. Instead of adding them like last time, we change it to subtract. And so then 2 over 2 minus 1 over 2 makes 1 over 2. And that doesn't even have any issues of like being bigger than pi. So the final answer on this one would have been multiply. You just multiply the front numbers, you divide the front numbers, and you subtract the powers. Final answer, 1/2 cis pi over 2. Of course, if it was just that easy, everybody would be like, yeah, you'd be done so early, it'd be like, what's wrong? What happened today? And I could actually have time to grade the lab. But no, it's not that easy. Because the third thing comes along, and it's squaring something. All right, 1 plus I. Would you agree that that's a place that's not in polar yet? Yeah. Make it be in polar. And then we'll talk about what happens when we put it to a power, like squaring it or putting it to the 3rd or the 4th or the 5th. I'm going to pause for a second. I want you to give that a try. You should have figured out that this was right over 1, up 1, right there. 1, 1, what? Square root of 2. Oh, I know this one. It's the 45, 45, 90, except we don't say 45. We say pi over. Final answer, what cis what? Root 2 cis what? Pi over 4. There, that's the polar representation for that point. Polar complex. All right, so this complex number, x plus yi. Don't let that freak you out if they say, put it in x plus yi form. Then it looks like this. You look really outraged about something. What? What part is killing you? Is it the root 2 part? Do you get that part? You've just forgotten the 1, 1 root 2 triangle. No? You don't know that one? I mean, you do know that one? Okay, how about this? 1 plus 1i. Does that help? And this is the I direction. Have you missed a few lessons? No. Okay, all right. Okay, having a moment. I get it. I have had those before. I know what you're talking about. All right. So this is the square root of 2 because a squared plus b squared equals c squared. And then this is a classic right triangle that you theoretically have memorized. And so if that's a 45, it's the same as pi over 4. So yay, I've got cis form, but what happens when I square it? Okay, well, what happens when I square this? 1 plus 1i. That you can do. Would you please square 1 plus 1i by doing it this way? Go ahead, multiply it out. That's typical ACT math. Everybody has to be ready for that one. Because you have to know one little factoid about eyes. What is it? No, yes, they do. Yes, that's true. But I is the what? Good. I is the square root of -1. But even better, what's I squared? Do you know? -1. Awesome. So hopefully you did 1 times 1. The first outside inside last thing. That's 1. That's I. That's another I. And then that's I squared. And that's -1, which cancels out the +1 and just leaves 2I. Ooh, that's kind of weird, but it's true. Do you get what just happened there? Oh, dang, I thought it was like an Easter egg. But no, it's just a calculator. It looked like a phone for a second. I'm running a little low on my fund. All right. 2I is 2 in the I direction. So the answer to this, which is that squared, is that it goes up here. A dot that's at pi/2 that's way up there. Over 2, or over 0 and up 2I. Okay, so again, you can't just look at this and go, well, of course, if I square it, it'll move up there. That just doesn't make any sense to me either. All right, but how do we square something in cis form? What would seem logical to you? Multiply it by itself, so square root of 2 and you square it. That part's actually right. You do square the square root of 2 because it's squared here, right? But I have a neato saying that I think you'll be mildly annoyed with, but will probably work for you. Ready? The guy who invented this, his name was demoivre. It's the French pronunciation. It looks like demoivre, but you'd say it demoivre. Okay? So to do this, Mr. demoivre figured that it's all about demove of the exponent. Demoivre is where is all about demove of the exponent. Okay, so we square that one, but we don't just square that one. We put it in the front there. Now I could do a proof, but it would take like half an hour, and all it would prove is that that works. Okay, and I know there's some value to that, but there's also some value to having a little bit of time to do your homework too. So what's a square root of 2 squared? 2. Cis, what's 2 pi/4? Pi/2, and that's the answer. Isn't that the same thing as what we just did a second ago, which was also known as 2I? Yeah, 0 plus 2I is the same thing. Think about it. If you were going to graph this one, you'd go to pi/2, which is like up there, and then you'd have to have the R be 2. So we have the dot up there before it worked. 0 plus 2I is the same thing as that. Now, here's the reason that you don't want to just say, well, I can just see a kid thinking this. If I'm supposed to put it to the 3rd power, and I know this was like, let me think, square root of 9, 4 is 13, cis, whatever angle, that would be a complicated one, but I have this one, the square root of 13 cis whatever. I'll just make it into this, and then I'll times it by itself because I know how to do that. Well, that would be great if we only squared them. What if we put it to the 3rd? Or to the 4th or the 5th? Demoivre still works even if it's like this. And would you want to have to write out 5 of these things and multiply all the different permutations and combinations of that and add them all up? Ick, gross. You wouldn't want to do it. But if I could have cis form, and I put something in cis form, like that other one could be written in cis form, but it's complicated. We'll get back to that in a minute. 3 cis pi/2, for example. Then I could say that's the same as 3 to the 5th, because it's all about the move of the exponent. That one can come on here and be 3 to the 5th, and that one becomes 5 on the top. Remember, a 5 is really a 5/1, right? So I'm timesing it by the inside. If you want to say it's times here, that's fine. but really, don't ever put it on the bottom because 5 is not the same as 1/5. And don't put a 5 on the top and the bottom. You know what I mean? If you put a 5 on top and the bottom, you really didn't do anything to it. It's just timesing really by 5 in the middle, but I like to think of that as move it up 5 pi over 2. So the kid happily goes along, figures out what the heck 3 to the 5th is, some disgustingly huge number, and then does cis 5 pi over 2, and the teacher marks it wrong. Dang it, I lost 5%! Why would I lose 5%, MA? And it's so easy to forget that. This is beyond pi, isn't it? It's quite a ways beyond pi. So we got to figure out where it is, and then give a good name for it. Would you agree that's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 is up there. 5 pi over 2 is right there. So really we should have said what? Just pi over 2. 241 cis pi over 2. 243 is it? How dare you? Try to do it in your head. Oh, okay. Okay, so that's demoivre. And we will really need that when we move up to the next level, which is to do this. Just a little pre-teaching. We've done things like 2. We could easily do things like 5. But what would it mean if we put it to the 1/3 power? Does that mean square root? It's close to square root. Cube root. It means the cube root of this. So don't I just put this to the 1/3 and that to the 1/3? It's not that easy. It's not that easy because why? Do you remember before when we would have to have n equals 0, n equals 1, n equals 2 on those kind of problems? It's going to be kind of like that. There's a whole bunch of answers. It's not just one answer. There's a bunch of answers. Okay, so we're going to do the plus 2 pi k thing in here. And anyway, that all happens tomorrow. And then the next day, I clear up all the last questions of like everything you'd have to know. Then Thursday, we take a review, and the Fridays, we take the test. Okay? So this Friday is the test on this stuff. All right. Is there anybody who's anybody going to be gone or something? I heard some mumbling about that. Okay. All right. If I were you, I'd try to take it Thursday after school so you could be, like, you'll all be all reviewed up for it. You'd love yourself later that you don't have to make up a math test. But if you don't have time Thursday after school, you can always take it Monday. All right. So that's what's coming next, and it would be the 3/3 roots of 3 cis pi over 6. All right. Anyway, by the way, if it was 4th root, take a wild guess how many answers there are. 4. There's 4 4th roots. There'd be 5 5th roots. I think you get the idea. All right, so let's actually get to the homework. Oh, wait, one more thing. Yes, this part. I want to make sure I covered this part. If I said that there was a place over 1, up 7, would you agree that that would be 1 plus 7i? Do you get that to be more of a pain to make cis form for this? It's not that hard to find the third side. I mean, you could find it. But then what about the angle? See if this was the test today. Boom. We just transported you to Friday. If you can, make that into cis form. What do you do when you don't know the angle? You write it in some weird inversey thing. See if you can do it. I'll pause for a second and give this a try. Because I think this is going to come up enough that I should practice it today so that when you hit it tomorrow, it doesn't cause brains to explode. I do keep a roll of paper towels in my cupboard, though, just in case. All right. Hopefully you figured out the third side. Square root of, I hope you've used this trick a lot, because a squared plus b squared equals c squared is really slow. 1 squared, 7 squared, 49, and 1 makes 50. Square root of 50, raise your hand if you did it that way. Awesome. Then, square root of 50 cis, what, RS? Square root of 50, cis, what's this part? Don't know? Ask the smart kid next to you. No, I said smart kid. Oh, sorry. Go ahead. Either side of you is a smart kid. Inverse tan of what? TOA, opposite over adjacent, and it's always about this angle. There you go. Boom, that's how you'd say it. Raise your hand if you had that one before he did. Like, all right, awesome. Now, one last thought. You started with a picture on that one, right? Think about it for a second. Couldn't you have recreated the picture from the question? So like Jeopardy. Here's the answer. You know, what is Americana or whatever? You have to form the answer in the whatever. I never got that straight. Must answer in the form of a question. Okay, so anyway, what if I said 5 cis inverse tan of 3/4? Could you make sense of that? And if so, tell me what it is in rectangular. Because that's not rectangular. That's polar complex. Complex polar. TOA. Did you realize we were talking about TOA, opposite, adjacent, that must be 5, and then this angle, I don't know, but I really don't need the angle to get the rectangular, because the rectangular is just that and that, 4 plus 3i. Raise your hand if you had 4 plus 3i. Awesome. Okay, so I think you're really in pretty good shape now. You just have to be able to move demoivre and about exponents, and it's all about demove of the exponent. So to sum it all up, if you had this problem, 5 cis, so I'm half the time just figuring out what the cis form is part of the problem. Like they'll tell you the rectangular form. Then you got to find the cis form. Now that you got the cis form, then they're going to ask you to like put it to the 4th power. You go, oh, so it's, I'm just going to write a few 4s up here. It's about the move of the exponent. And then that one's gone because it got moved. And there we go. That would be 5 to the 4th, ridiculously large number, cis pi. Any questions? All right. So let's go look at your homework. I'm going to pause for a second while we pull it up. All right, so here we go. You're going to be doing the first 2 on the page, but you're going to skip actually this one. And then you should do that one also. These 3 on this page. Remember, I pick out ones that I know would be good for you to do. As in, they're all important. I really try to pare it down to a doable amount. And your job is to do it. And this is a bit of a pain, but if you're going to cube W, you do not want to put that to the 3rd. That would be super painful. You'd want to draw it and figure out, ooh, it's actually the 1, 1 root 2 triangle, which it is. Let me show you. I go over 3 root 2, and I go up, no, down, negative 3 root 2 in the I direction, and then you quickly realize those are the same size, and therefore it's a 45-degree angle, etc. So you got to get it to cis form first. Half the effort is just figuring out that this thing is that squared, which is 18, by the way, 3 root 2 times 3 root 2 makes 9 root 4, which is 9 times 2, which is 18. 18 and 18 is 36, and the square root of 36, and I know that one. What's the square root of 36? 6. So that third side is actually a 6. So all that work just to figure out it's 6 cis pi over 4. Nope, just screwed it up. What's the slight little mistake there? It's not pi over 4. It's negative pi over 4 because that's a 45-degree angle. True that, but it's a negative. All right, so 6 is negative pi over 4. And now I got to cube it. Oh, so now it's all about demoivre of the exponent. This 3 is going to come down here, and wherever 6 to the third is. Thank you. 216 cis. And remember, the 3 also goes in here. And that's negative 3 pi over 4. You have to know if that's bigger than pi or negative pi, and it's 3/4. That's less than a pi, isn't it? So therefore, that one's okay. And we're done. Sweet. You just did a demoivre. Do 46, where you'll have 2 of those, and then at the end you multiply them. You remember on the multiply kind, you multiply the front numbers, and you add the angles. Okay. This one where you divide. After you do the demoivre part to get the top, then you'll divide by, which means you divide the front numbers and subtract the angles. All right, so there's 3 on that page. I think you'll see I'm going to keep it doable. On this page, I'll only need you to do 1, problem 63 itself. And last but not least, 1 problem off this page, problem 53. All right, you may want to write down which ones to do. I know you don't have the iPad to cross them off and everything, but it was do problems 45, 46, and 48, 63, and 53. I apologize that they're not like in a particular order. We use snips from the free open source honors pre-calc book written by those guys out on the West Coast. So, okay, and that's all I have for you for today.